Hi everyone, and welcome to this session during the Risk Awareness Week. Today I'm joined by Sam Savage and Shayne Kavanagh, and this is the second session I'm doing with Sam. Make sure you watched the replay of the previous one if you missed it. If you missed it yesterday, but today we have something amazing lined up for you, and I just want to remind everyone to keep this interactive. Ask questions underneath this video, talk to other participants, just use this opportunity to interact with other people watching this session and ask our amazing speakers questions. So Sam, over to you. Tell us what we have in store today for this session.
Sure. So I'm the executive director of probabilitymanagement.org. We're a nonprofit that's trying to make uncertainty actionable. And we've developed open standards for communicating uncertainty. I like to think of we're doing for uncertainty what the Hindu Arabic numerals did for numbers. And there's this important concept of storing uncertainty in a library that can be used in decision-making in a really unambiguous and auditable manner. One person who's applying this idea of these, we call them SIP libraries, is Shayne Kavanagh at the Government Finance Officers Association, and he'll be showing you an interesting crowdsourced application of this when I'm done introducing the basic technology. So let's start with a decision, very classic decision under uncertainty. We're purchasing something to sell for the Christmas season, and the demand is uncertain, but our best guess is 100,000. We pay $30 for these, we sell them for $40. Here's the problem. We have to order 6 months in advance. We only get one shot at it. And if you look at this, there's a $10 margin on each one. If you sell 100,000, well, let's order 100,000 because that's our best guess. If you sell 100,000, you make $1 million. Yes, but you know it's uncertain. So the boss comes in and says, hey, Alex, what is our profit going to be? And, Alex, you say, I don't know, boss, because I don't know what demand is going to be. And the boss says, give me a number. And you say, would you settle for an average? The boss says, well, sure, if it's all you can give me. Well, look, on average, we're going to have a demand of 100,000. We'll sell 100,000, and so we'll make $1 million. Well, not so fast, because if the demand is below 100,000, you're not going to make your numbers. If demand is above that, you're stuck because you only ordered 100,000. So what I'm going to do is use this concept of a SIP library, and I'm going to go into this cell. This is all. This is the free software available at our website, and we'll discuss it more in further sessions, and we've got all kinds of videos and stuff on that. But I'm going to plug a SIP library of demand into that cell. And when I do, we see a little distribution shape. And now we're actually looking at one of 1,000 possible demands. And the library itself is now over here. And if I open it up, we can see it's got 1,000 different demands. I go back over here, and I can actually scroll through the trials. So there's trial 1. Let's look at trial 2. Trial 3. I like to think of these as like Rick and Morty universes. If you know the Rick and Morty cartoon show where they're parallel universes. But notice something right away. If the demand is only 75,000 instead of 100,000, I only make 23,000 in profit. And if the demand is above 100,000, like 103,000, I still only make my $1 million. There's basically an if statement in here. You can't sell more than you ordered. So once I have the SIP library hooked up to this thing, I can now define profit as an output cell. Let's just say that this cell down here is, I want 1,000 profits, not one. I click on that and bingo, I get a little distribution shape. And on this other sheet over here, I have 1,000 profits. We call these arrays SIPs, stochastic information packets. So a SIP of demand goes in, a SIP of profit comes out. And now this is a native Excel model. I could share this with 1 billion of my closest friends. The tools help you build such a model, but it's all just using native Excel commands, and I'm going to get the statistics on that. Now what we see is, let me scroll to the average input. So that's not one of the trials, that's the average of 100,000. And when I put in 100,000, I get a profit of 1 million. Right. But on average, I get 600,000. That's what I call the flaw of averages. I mean, this is disastrous. This is not close enough even for government work. Now, speaking of government work, I'd like to introduce Shayne Kavanagh, who's the Senior Research Manager for the Government Finance Officers Association. Shayne is a terrific pioneer in the field of probability management. By the way, we define that as managing uncertainty in terms of auditable data. And Shayne and I have worked together, my gosh, since 2013, I think. And Shayne, if you'll introduce, I'll stop sharing here, introduce the project you're working on there at GFOA.
Happy to do so, and happy to be here with Alex and Sam and the rest of the people joining us. So I'm going to go ahead and share my screen, and you will hopefully see my Excel document right now. And just a little bit of background before we get into this document. You may be wondering who or what is the Government Finance Officers Association. We are a nonprofit membership association of about 20,000 local governments from across the US and Canada, mostly at the CFO level, but also includes CEOs and middle managers and other folks in the finance profession. So really the bottom line is, if you live in the US or Canada, there's a very good chance the CFO of your town is a member of our organization. And as Sam mentioned, we've been working with probability management for quite a while. And the reason being, of course, that in public finance, just like pretty much, I think, every other industry, uncertainties are endemic. So we've been thinking about how do we bring this technology to local governments. And for a number of years, we've been building models that help local governments determine the optimal amount of rainy day funds to hold. So in other words, governments essentially self-insure by holding these rainy day funds. And a perennial question is, what amount of funds is the right amount? And we've been doing that for a number of years, but as a nonprofit, our goal is to spread good financial management practices far and wide, and the models that we've been working on are essentially one government at a time. So what I'm going to show you here today is a very exciting development from our perspective, because this is bringing probability management to the masses of public finance. So with that, I'd like to jump into the model and show you guys a little bit about what we're up to. So in this case, the problem is not rainy day funds. The problem is another uncertainty that local governments have to deal with, and that is making your forecast. So you forecast one thing, your expenses are another, there is a gap, and that gap can cause you problems. So having a better sense of what that gap is and how to manage it could be a very valuable thing for a local government CFO. So in our model here, we first have to pick an economic period. So the data we gathered, and I will get to where that data came from, comes from different economic eras, shall we call them. And we're going to go ahead and say, well, we believe that the time we're making this forecast in right now, and we'll say not 2020, but a hypothetical right now, is kind of analogous to pre-2007, shall we say. And then we'll think about, well, all right, what type of taxes do we have? Well, most local governments have a property tax, so we'll have that. And we believe that we're going to forecast $10 million for that. So imagine 10 million. And so you've got a little simulation there, a distribution of possible tax numbers, and we're in trial 1 right now. Sam mentioned you can scroll through the different Rick and Morty universes. So we went to trial 2. We could do that if we go to trial 3, so on and so forth. So let's go ahead and add some different taxes. Let's go ahead and do sales. So we're going to have, let's say, 5 million in sales tax. We'll add that. There's another distribution, and we'll go ahead and add one more. We'll go ahead and do utilities, and we'll say we've got 5 million in that. So that gives us a total of 20 million. Our goal is 20 million. So let's say that's our budget. We want to spend 20 million. And what we're looking at right now is the chance of reaching our goal given the distribution of these different types of revenues. And what this model is telling us is, given the distribution of the different types of revenues we have, we've got a 71% chance of meeting our goal, which is pretty good. Now, it's pretty good in that it's better than a coin flip, but in most local governments are a little more risk averse than 71%. So they might say, well, you know, we actually rather have a goal of 19. We're not going to plan to spend up to how much we think we're going to get in revenue. So we'll go with 19 as the goal, and they've got a 99% chance of reaching that. Is so much better, much more relieving of their stress, right? So now we are back here assuming it was the good old days of pre-2007, but we are not in the good old days of pre-2007. So we might want to look at a different era. Let's look at the 2007 and 2008 where things were starting to go a bit sideways. So we'll put that in. 97, that's not great. It's not as good, I should say, as 99%, but it's still not bad. However, we're not in full-blown recession when we look at the 2007, 2008 period. So maybe we say, well, 2009, 2010, that's kind of right in the middle of the Great Recession. What does that look like? Now down to 85% chance, right? So not so good. And if we had gone back to, or not as good, and if we went back to our original goal of 20, it would be quite bad, where you're getting 37% chance of meeting your goal. That would be, I think, completely unacceptable. So no matter how risk adverse you are, and well, maybe somebody would accept that, but not too many governments. And so we might say 19. Let's look at 19.5, how that does us. So different chances, maybe 18.5. You know, we think we might like to raise our chance back up. So it allows the possibility to try out different combinations of goals and revenue forecasts to see what sort of chance you have of reaching that goal, and also trying out different economic periods to explore how the economic circumstances at the time impact the chance of meeting your goal. And just kind of one more illustration, let's say we're back in post-2010, which is of course a pretty good time of growth. If we assumed it was something like that, we're back to 100% chance. So this model is taking a combination of economic eras, different types of revenues that have different levels of volatility, and combining all those to help local governments estimate the chance of meeting their spending goals given their forecast. So now one of the questions you might have is, well, where do these numbers come from? And let me just show you right here. This is a little graphic, and this little graphic shows us a little histogram of the historical data that is being fed into this model. So we asked about 30 governments of different sizes and types to give us a history of their forecast versus their actual revenue. And we use that history of forecast errors to feed this model. So in other words, these distributions right here are based on the actual experiences of local governments from the 4 different economic eras, those shown right here, that we have in the model. And I think one of the beauties of this model is that as we roll it out and engage GFOA members in working with it, the model can be updated. So let's say government 31 comes along and they say, well, I'd like to contribute my history to the 30 governments you already have. That's great. We can drop that distribution in and update the model. So as we go, we'll expect to add more distribution or more data to this model to have additional governments represented in it. And as we get further down this path, there's going to be, I think, many opportunities to explore possibilities to upgrade this model, such as maybe looking at different types of taxes that we have in here, and otherwise expanding the capabilities of this work. And with that, Alex, I will hand it back to you, or Sam, if you had additional questions or thoughts that you wanted to contribute.
Well, let's let Alex kick it off. And this is such a new approach, and yet it's so simple.
Exactly, and this is just something I want everyone who is watching. And by the way, don't forget to write comments and questions underneath this video. But to everyone who's watching, I mean, this is truly the new frontier of quantitative risk analysis and decision making. It literally is crowdsourcing distributions, because as a risk practitioner, as a CRO of a large business, the most common excuse that I hear is that we don't have enough data to simulate uncertainty and to make quality decisions. And individually, what Guys and what Shayne has proven, that individually, each of the local governments probably wouldn't have enough historical data to justify a proper model. But collectively, using historical accuracy or errors in forecasts and pulling it all together, but more importantly, storing it on a cloud and making it accessible to all the local governments. I mean, that is just absolutely amazing. And it allows you to, as you get more and more data, as Shayne mentioned, it allows you to test all the different hypotheses. Are local governments on the East Coast different to West Coast? Are there any clusters between different different regions of US or Canada that add additional error or reduce potential error? So many amazing things you can do in terms of analysis. But truth be told, that's a little mathematical nerd inside me talking, because as far as the CFO is concerned, for all the local governments, they have this amazing online calculator which allows them to validate and stress test their own forecasts, their own management forecasts, and allows them to to really test different hypotheses and see how their forecasts would look like under different economic conditions. I mean, this is such a powerful, and it's so simple. I mean, you guys, it's a little bit unfair because you guys at probability management are quite cool. You do a lot of, you are wizards with Excel, so it looks amazing. But it is a pretty simple model. So I'm amazed.
Absolutely. By the way, I haven't tried it, but if you put this model in like on OneDrive, you could run it off your smartphone, right? Because Excel is everywhere, right? You do Excel online. But you made one comment that I want to play off of a little bit. I've seen it myself. You said, look, people say we don't have enough data to do probabilistic analysis. That's like saying, oh no, I'm too dirty to take a shower, or I'm too stiff to do yoga, or I couldn't learn how to use a parachute now. Can't you see the wing of the airplane is on fire? No, it's when you don't have data that you do need to do this. And it's like horseshoes and hand grenades. Close counts. Famous statistician George Bach said that all models are wrong, some models are useful. And I'm quite sure Doug Hubbard participates in your program as well.
Yes.
And Doug and I have both been in the trenches on this. I discovered at one point that we were both telling the same lame joke about the same lame excuse people had for not doing this. And the joke is that the two guys hiking off in the woods, and they discover they're being tracked by a bear. And so one guy pulls out a pair of track shoes from his backpack and puts them on. The other guy says, you can't outrun a bear with track shoes. He says, I don't need to. I just need to outrun you. You don't have to have a perfect model. You just need to outrun the people who don't have a model. And that's pretty much everyone.
Yeah, that's so true. I've literally used that anecdote 3 times with some of the board members at work. Because every time they keep asking me about, how do we get perfection in the model? And I'm trying to communicate that it's not about perfection. It's just an improvement on the deterministic and on deterministic decision making. And it's so easy. Any sensible stochastic analysis is a huge improvement on the deterministic model already.
I think there's something else subtle here that does not get enough attention. Every time Shayne changed something, 1,000 Monte Carlo trials took place instantaneously. That made it interactive. I always have to go back to Steve Jobs' statement that a computer is a bicycle for the mind. You can ride these models like bicycles, and that really engages the user. So now to quote Confucius, I hear, I forget. I see, I remember. I do, I understand. Build an interactive model like this, and you're going to engage people. And so speaking of engaging people, is it, I hope it's not insulting, Shayne, to call the people we're working with guinea pigs, but not everyone is up to this. And GFOA has a wonderful group of very smart CFOs, and we're trying to get a group of them to come forward and really experiment with this. And I think you've already got some lined up, right, Shayne?
Yeah, Sam, that's correct. We do. And a number have actually already done it as part of the risk modeling work that we do with the rainy day funds I mentioned earlier. So it's a very encouraging sign is that this is not a new thing for public finance at this point. I think a fairly significant portion of GFOA members are pretty well aware of the work that we're doing with probabilistic analysis, and a number have actually participated in it directly already. But this will definitely be next level participation, as Sam was saying.
And this is kind of another aspect of this. I'm pretty sure I mentioned this in my last session, but we don't assume any statistics. If you've had extensive training in statistics, it only takes 45 minutes to repair the damage. What damage? It's called post-traumatic statistics disorder, PTSD. And so, for example, Shayne, why don't you change your goal down there to 20 again? 71%. Change it to 21. Okay, 15%. So one of the things, you got to avoid triggering PTSD. One of the words I no longer use is probability distribution. Why? Well, first, it triggers PTSD. Secondly, it's got 9 syllables, for God's sakes. The word I use now is chance. The chance of whatever. So what's the chance that it's at least 21, 15%? Let's go to 20.5, Shayne. 38%. So we don't talk about probability distributions. We just talk about the chance of meeting your goals, whatever your goals are. And by the way, that is the definition of a probability distribution, but please don't tell anyone.
And exactly, Sam, I totally agree. And so I wanted to ask this question. I mean, this is this is quite intimate because people are just amazing excuse generators when it comes to good quality decision making. And so you guys had the guts, the balls. I don't know what the word is. You had the
foolishness might be the word you're groping for here.
You had the foolishness of taking away one of the most common excuses is that people don't have enough data. So you've taken that away from them, and now you have poor local government CFOs. They have so many things to worry about, and now they have no longer can use that excuse that they don't have the data. what other excuses do they use? Because at some stage it becomes psychological that this is the simplest model I have ever seen. It could be so powerful for decision making. It allows you to stress test your forecasts. It allows you to improve your forecasts. It just gives so much amazing data for the decision makers to talk about and to budget. But surely they're not, surely people are not lining up to use it in their annual budgets. I mean, what are some of the excuses that you hear, or maybe what's some of the good feedback you heard from some CFOs who I'm guessing are in the minority at the moment, but I'm sure there are some early adopters.
Sure. Yeah, I could take that. And Sam, you feel free to jump in, of course. But I think my experience has been that all the CFOs feel the pain, right? Because you got to start out with describing why you would want to do this, like not what it is. And like the why is like, you have a rainy day fund, to do my rainy day fund example. You know that the amount you have in there is not really connected to your risk in a meaningful way. And everyone knows, since it's essentially self-insurance, that's probably not ideal, right? So they can like grasp that why. Or in the case of the forecast, like they know the forecast is uncertain. The only thing they know for certain about their forecast is that the number they put in their budget is going to be wrong. Like that's like pretty much the only thing that they can bet on 100%. And they know that difference is something that they have to manage. So that why is very compelling. So I think leading with why you'd want to do this is, I think, been an important part of our work. And then Sam kind of alluded to another important thing, I think, which is keeping the presentation, and you said it yourself, Alex, is keeping the presentation very simple. So we're not kind of overcomplicating the presentation. There's just one little thing they look at over here, the chance and the goal. And I'll share with you an example from our very early work, which I think is kind of instructive here. So this is from kind of our very first probabilistic effort with Sam, and this is relating to forecasts. So it's actually pretty similar to what we were just talking about, where this particular city was trying to think about probability and forecast, and the analog that they used, in the metaphor they used with their city council, was that if we budget right at our best estimate, that's pretty much in the middle of the bell curve, and we're giving ourselves a coin flip's chance of having a deficit, right? Because you're right at the middle of the bell curve. You've got a 50% chance of being over. You've got a 50% chance of being under. No city council is like, I'd like to take a coin flip chance of having to like lay off city staff in the middle of the year. And this is relatively sophisticated, this picture, compared to this. So, I think we've evolved our game a little bit to even get beyond, as Sam said, probability distributions are a bit intimidating to people. So even getting beyond this to simplify the presentation, and to the extent that we can use metaphors like coin flips and other things that people get, it reduces the intimidation factor.
Yeah. Back to excuses that people make, Alex. So Doug Hubbard and I have got something we call the top 10 list of lame excuses for not modeling probability. I mentioned only one of them. I'm not going to give them all to you, but we're going to publish that out on the website pretty soon. It's actually, I think, it's in the next edition of The Flaw of Averages. It might be in one of Doug's books now. One other thing that's really important here is that what we're doing is auditable. It's based on auditable, repeatable data, number one. And number two, you have to state it with caveats. If you have no SIP library, then you just have a number. Here's the number 20. What's the chance the number 20 is greater than 20? 0. What's the chance it's less than 20? 0. It's just a number. Once you start talking about chance, you can always say, well, if your forecasts are anything like the forecast of these other 40 cities, you got a 38% chance of achieving your goals, right? It's an anchoring point. And it just is so much like riding a bicycle. You have to engage people, and it's, if only, gosh, Shayne, what would you say you go to GFOA, I would say only a small percentage of them will really glom onto this, but it's enough to transmit the, you know, the contagion of probability. What percentage would you say if you got 10 people in a room, how many would respond positively? I mean, at one of your conferences, GFOA conference.
Sure. Yeah, well, I mean, since we are all, and I think we're talking to the inside crowd at this point, so I can use the word probability distribution. So you guys have all seen the probability distributions for uptake of new ideas, right? And very popular thing in Silicon Valley and the entrepreneurial space. And I think they say like somewhere between like, you know, about 5% of people are the early adopter types. Like those are the folks that line up in front of the Apple store at 3 in the morning to get the latest iPhone. You know, that's probably true in the GFOA world as well. There is a small percent of people that want to jump right on board. And then kind of 10% are the kind of not quite bleeding edge, but still like would be willing to try new things. So it's probably very similar in the GFOA world, where I'd say, Sam, in that room of 10, I could probably get one of them to try this out, but then the kind of rest are the followers, right? Where, you know, once they see this succeed, well, now this sounds so much more reasonable. And this has been our experience with the rainy day fund analysis. So that's kind of grown in popularity quite a bit as more and more people have done it, and the positive results have come in.
And another analogy, Alex, about you don't have enough data to do this, right? I like to think back, you know, it turns out the light bulb was invented like in the 1830s. Edison perfected it like in the 1880s or something. And finally, there was the first power grid in like 87 or something in New York City, where Edison was lighting light bulbs from some generator somewhere. So when you say, I don't have enough data to do probabilistic analysis, that's like saying, I don't know how to generate electricity. Well, right, neither do I, but I use light bulbs. What we're doing here is like a specialization of labor, you know, like I think Adam Smith talked about that. Yeah, you got the people who know how to generate these distributions, great. Have them do it in the basement somewhere or wherever. And you have the other people who can use the stuff like electricity. And in that analogy, probabilitymanager.org has developed the AC current standard for communicating probability distributions, which is a pretty abstract thing. You walk into a cocktail party and tell people that you do that, you don't get invited back.
I'm going to do it just for the sake of it. Just at every party I join from now on. But both of you have mentioned two very, very important points that I just want to explicitly state for everyone who is watching us. Point number one is that we have to be real about the uptake. And the uptake for quality decision making, for probabilistic thinking, is no different to uptake to any new technology or just anything new and modern and scary and amazing. Because this stuff is amazing, but it doesn't, unfortunately, break the kind of the human silos. So when we are trying to implement this type of risk analysis in our work, that could literally mean that out of all the executives and all the board members, there could be just one person who is our best bet on convincing to give it a try. Because one of the other excuses that I hear all the time is that I've presented probabilistic decision making to the board and most of the comments were negative. And they say that's a bad thing. Of course they would be negative, because out of the whole room, there's probably, if you're lucky, a single person that understood it and is an actual kind of early adopter. That's normal. And in fact, we should be we should be focusing on trying to identify that one individual within the corporation instead of convincing everybody that this is kind of the amazing thing to do.
Well, I agree with you, but many more are getting it now because of the interactive models. So Shayne, change your goal to 20.6. 20.6. Okay, change it to 20.7. Now hit the undo key. Control Z. Control Y. Here's the way to think about This is what I call limbic analytics, connecting the seat of the intellect to the seat of the pants. And the vision you should have here is in the movie Jurassic Park, there's a scene where Sam Neill is waving a railroad flare in front of a Tyrannosaurus Rex and waves it back and forth. Now we're talking about effective communication with someone who has a very different perspective on life than you do. But the Tyrannosaurus catches the movement, then Sam Neill throws the thing off into the jungle and the Tyrannosaurus lumbers after it. When you're presenting to the board, think of them as a bunch of Tyrannosauruses, and you've got to get their attention with something that moves and teaches them. So I blame, look, statistics have been around for a long time without computers. Computers change everything. Being able to do 1,000 Monte Carlo trials per keystroke takes us to a completely new realm of experiential understanding. People call this tacit learning. You know, to learn how to ride a bicycle. You can't write a book on how to ride a bicycle. And I don't think you can write a book on learning this stuff. But you say, oh my gosh, the chances go down when my goal goes up. Right.
I totally agree. Yeah, exactly. And this is the second amazing point is that, and I think, I can't remember what you called it last year during the Risk Awareness Week, because you had this making uncertainty visual or visible. It's just the whole concept of not hiding uncertainty.
Keeping the uncertainty alive.
That's the one. That's the
You're
one.
Keeping uncertainty alive. And so let's just go in here. We have a 28% chance of meeting our goals. Well, if you're going to lower your goal, go down to 20 again, Shayne. Just take it down to 20. Your goal is 20, right? And I'm a little uncomfortable with that. Well, so how do I get it below that? Let's go to our utility franchise tax. You can't do anything about that. Property, let's go to property. Reduce that to 9.5. So now we're down to 1950. Go down and put 1950 down there. Just see what our chances are now. So we've kept the uncertainty alive. When you reduce it, your property taxes from 10 to 950, it immediately ran it through all the uncertainties and tells you, well, you know, I got a 71% chance. And hit undo, Control Z, just Control Z, 38%, Control Y. Which of those numbers do you like? Are you now willing to back off on our estimate of property taxes? Because here's the response. By the way, the magic of the spreadsheet in the first place, I think it was the first spreadsheet was VisiCalc in 1978 or 79. It was this interactive ability that really brought it to people's attention and allowed them to use what I call today limbic analytics to tie the seat of the intellect to the seat of the pants. I wonder if it makes sense to talk about some of these educational things that we're doing here, Alex, at the nonprofit.
Sure.
If I can share. See, I think I got
Sam,
it.
while you're doing that, maybe I could just share one more thing.
Please. You share again then.
No, just to add on to what Sam was saying.
You'll have to share again.
Oh, well, that's okay. I was just really,
you got it.
Yeah, add to something you were saying, so no big deal. But I think, Sam, you were kind of getting at this is in our work, one thing we found, I think, instructive is to be mindful of the paradox of choice when presenting this stuff. And if you're not familiar with that paradox of choice, it's basically the more choices you get, the less likely you are to make a decision. And the kind of famous study about this is the jam study, where the experimenters put like 30 types of jams out. They got people to look at them, but no one actually bought any jam. They put 3 types of jam out. They sold a lot more jam. So what this has to do with probability and kind of this type of analysis is the more variables are, the more kind of different permutations there are. There's a paralysis that sets in, like in Sam's example, he just actually went through 2. You know, there's 1,000 trials in here and all sorts of different things we go through, but we just had 2 different scenarios we looked at, like this one and that one. And that's a lot easier for people to get their minds around. So I think limiting, kind of putting limiters on the discussion has proven very powerful to help people keep anchored and not get too lost in like what is essentially a set of infinite probability, infinite possibility.
Well, that's related. That's related to the whole concept of signal to noise ratio. So, for example, in your 30-hour statistics course, there were actually 30 minutes of stuff that you really need to understand and take with you. But they didn't tell you which 30 minutes were the important ones, right? So you throw the whole thing out. And, well, you know, they've been hired to teach a statistics course. They're doing their job. They're supposed to teach 30 hours. You know, it's kind of, it pollutes the environment.
All right, Sam, do you want the screen?
Sure.
All right.
So,
so for everyone who wants to learn more, where should they go?
Yeah, so here, first of all, there's probabilitymanagement.org. You know, we are the nonprofit, and probabilitymanagement.org. But I've taken you to our education page here, and I just released a course through Stanford Online and edX, which is an introduction to probability management. You know, these courses are free. I think, Shayne, you've been through it. I mean,
yeah,
there's only like an hour and a half of video all told, isn't there?
Yeah, they're all very short and watchable videos.
And you know, you can dole out a whopping $89 and pass the tests and stuff, and then get an actual certificate for it. But it's an introduction to the kinds of things we're doing. And again, the discipline of probability management is really defined as communicating uncertainty as auditable data. And we're not limited to Excel. You can do it in R, you can do it in Python. You can really do this stuff with 1,000 people with abacuses, right? Each one in their own Rick and Morty universe, right? Doing the calculations in that universe. And at the end, you take all 1,000 calculations and you've got the uncertainty.
And if I just might add, I think the exercises and simulations that you do as a student in this course are quite valuable.
So that's really good stuff. So there's some practical exercises as well.
By the way, that's another very important point. There are two aspects to learn. You know, there's the, oh, I know what the handlebars are on a bicycle. I know what the seat is. I know what the chain is. And then there's riding the bicycle. Those are very different. And in that edX course, we have actual, you got to ride the bicycle. Now you can pass the course without doing that because there's some intellectual stuff you do have to know about the parts of the bicycle. And those are important to know. They're important concepts, like the fact that average profit was 600, but you plugged in the average demand and you got a profit of 1,000, that those two aren't the same. Oh, that's very important to know because that's why we're doing this, right? But that alone is not going to help you build the model. And so I do think that there's so many wonderful things you can learn over YouTube these days. Once it's a more interactive environment, or download a spreadsheet. So in the course, you download an actual spreadsheet and you manipulate the formulas, and you know, it is a much harder to teach than just remember these 5 concepts.
Totally. So I started going through that course already because Sam was very nice and shared it with me last week, and I'm still in the early lessons, but it looks amazing. So I highly recommend it to everyone. I think that was a very nice session. Thank you, Shayne. Thank you, Sam. We will see Sam in another couple of sessions during the Risk Awareness Week, and make sure you catch the replay of the previous session we had yesterday. And thank you, everyone. Don't forget to ask questions underneath this video. Thanks, everyone.
Thanks. Bye-bye.